Let me start with a confession that most scientists won't make publicly. Magnetism still doesn't make sense. Not because we are stupid, not because we lack equations, but because the explanations we repeat sound confident while hiding a deeper confusion. You were told magnets attract and repel. You were shown arrows and lines and neat diagrams. You were satisfied because the answers worked. But working is not the same as understanding. In business, I learned this lesson the hard way. When something works too smoothly, people stop asking why. And the moment you stop asking why, ignorance wears the mask of confidence. Magnetism is one of those things. Two objects pull on each other across empty space. No rope, no contact, no visible connection. And we say, that's just how it is. But that answer should bother you, because when you ask, what is actually pushing? What is actually pulling? What is really happening between them? The story starts to fall apart. We have formulas. We have predictions. We have technology built on it. And yet, at the deepest level, we are still describing magnetism, not explaining it. That gap between knowing how and knowing why is where the mystery still lives. What we actually mean when we say magnetism. When people say magnetism doesn't make sense, they usually mean something very specific. They don't see a mechanism. They see effects. They can predict outcomes, but they don't see anything doing the work, and that discomfort is justified. The simplest observation and the hardest one. Take two magnets, bring them close. They move, no contact, no visible connection, nothing in between that looks like a rope or a rod or a pushing hand, and yet there is motion. Now pause there. In everyday life, motion requires contact, a push, a pull, something touching something else. Magnetism violates that expectation immediately. The temptation to invent stories. Faced with this, people invent stories. They imagine invisible threads. They imagine flows. They imagine tiny hooks reaching across space. These stories feel satisfying, but they are inventions. Physics does not explain magnetism by telling a mechanical story underneath. It explains magnetism by describing consistent behavior. That distinction matters. What fields really are, not metaphors. We introduce magnetic fields not because they are intuitive, but because they are useful. A magnetic field is not a substance. It is not something flowing. It is not a hidden object. It is a way of describing how space itself responds to certain conditions. That's uncomfortable, because we like space to be passive. Magnetism forces us to accept that space can have structure. Why field lines confuse everyone. Field lines are drawings. They are bookkeeping tools. They do not exist as strings in space. When people imagine magnets tugging on lines like rubber bands, they've already left physics and entered metaphor. The field is real. The lines are not. Why explanation stops feeling satisfying? Here's the uncomfortable truth. When you ask, why does magnetism exist? Physics has no deeper answer. We can tell you how it behaves. We can tell you how to calculate it. We can tell you how it fits with electricity. But when you demand a mechanical story, something pushing something else, there is none. Nature does not owe us that kind of explanation. Why magnetism isn't separate from electricity? One of the great surprises of physics is that magnetism is not an independent phenomenon. It is electricity viewed from a different frame of motion. Change how you move relative to charges, and electric forces become magnetic forces. That sounds clever, but it doesn't make magnetism feel intuitive. It only makes it unavoidable. Why this doesn't make it understood? Unification does not mean explanation. Saying magnetism comes from relativity and electricity tells you how the descriptions fit together, not why reality is built that way. The discomfort remains. The electron story and why it disappoints. People often say magnetism comes from spinning electrons. That sentence is true and deeply misleading. Electrons do not spin like little tops. Their spin is a property, not a motion. Calling it spin borrows language from everyday life that does not apply. Again, a familiar word hides an unfamiliar reality. Why magnetism feels spooky? Magnetism violates our instinct that effects require contact. We accept gravity doing this. But magnetism feels worse because it can repel as well as attract. Something is deciding which way to push, and that decision has no mechanical story underneath. Why equations don't comfort the mind. You can write equations that predict magnetism perfectly. That does not make it feel explained. Understanding is not prediction alone. It's feeling you know what is happening. Magnetism resists that feeling. The honest position is this. We understand magnetism the way we understand chess rules, not the way we understand gears. We know what happens. We know when it happens. We know how to calculate it. But when someone asks, what is really happening in between, the answer is not satisfying, and pretending otherwise is dishonest. Why this matters? Magnetism teaches us a hard lesson. Nature does not promise explanations that match our intuition. It only promises consistency. If you demand mechanical pictures everywhere, you will misunderstand the universe. The misconception is not that magnetism is mysterious. The misconception is thinking mystery means ignorance. Magnetism is not unknown. It is irreducible. Where this leaves us, at the end of part 1, you should feel slightly uncomfortable, not confused, but unsettled. Because magnetism refuses to be reduced to pushing parts. It exists as a rule of how reality behaves. And that already tells us something profound. The universe is not built from mechanisms alone. It is built from relationships. Why motion turns electricity into magnetism, and why that still feels wrong? Because magnetism does not exist on its own. That statement alone already feels wrong to most people. The unsettling fact, magnetism depends on motion. If you strip the situation down carefully enough, magnetism appears only when charges are moving. Static charges produce electric forces. Moving charges produce magnetic effects. This is not an extra rule added for convenience. It is how nature behaves. And immediately, a question appears. Moving relative to what? Why relative motion is not a trick. In everyday life, we think motion is absolute. Something moves or it doesn't. Physics tells us this is false. Motion is always relative to something else. You can be at rest in one frame and moving in another, and both descriptions are equally valid. This idea is already uncomfortable. But magnetism forces us to take it seriously. A thought experiment that refuses to behave nicely. Imagine a wire carrying an electric current. Charges are moving through it. Place another charged particle nearby. In one frame of reference, the wire is neutral overall, and the particle experiences a magnetic force. In another frame, where the particle is at rest and the charges in the wire are moving differently, the situation looks purely electric. Same reality, different description, same measurable outcome. That is not philosophy. That is necessity. Why this feels like cheating? People often feel cheated by this explanation. They say, so magnetism is just electricity in disguise? Yes, but that doesn't make it simpler. It makes it unavoidable. Because now you must accept that forces depend on how you are moving relative to the system. That idea clashes violently with everyday intuition. Why length contraction enters the story. Relativity tells us that moving objects contract in the direction of motion. This is not an illusion. It is measurable. Now consider a wire with positive charges fixed in place and negative charges moving. In one frame, the densities balance out and the wire is neutral. In another frame, length contraction changes those densities. Suddenly, what was neutral is not neutral anymore. An electric force appears, and that electric force, when transformed back to the original frame, shows up as magnetism. Why this explains magnetism and still doesn't satisfy? This explanation works. It predicts the correct forces. It matches experiments. It unifies electricity and magnetism. But here's the problem. It doesn't tell you why reality is built this way. It tells you how descriptions transform, not why the universe chose those rules. Why unification is not the same as understanding. Physicists love unification, but unification often replaces one mystery with a deeper one. We no longer ask, why magnetism? We ask, why do space and time behave in a way that makes magnetism inevitable? That's progress, but it's not comfort. Why the speed of light refuses to go away. The speed of light appears everywhere in electromagnetism. Not because light causes magnetism, but because the structure of space-time limits how information and influence propagate. Magnetism is shaped by those limits. Again, this is not optional. Remove those limits, and electromagnetism collapses. Why this makes explanation feel incomplete. We like explanations where one thing pushes another. Relativity gives us explanations where descriptions change instead. Nothing pushes. Nothing reaches out. The rules change how measurements relate. That's deeply unsatisfying to the part of the brain that wants mechanisms. Why saying fields do it doesn't end the discussion. You can say the magnetic field causes the force. That's true. But then the next question appears immediately. What causes the field? And the answer is not a mechanism. It's a set of rules connecting charges, motion, and space-time. At some point, explanation stops being mechanical and becomes structural. Why this is not a failure of physics. Some people think this means physics has failed. It hasn't. Physics never promised to satisfy intuition. It promised consistency with observation. Magnetism obeys the rules perfectly. It just refuses to explain itself in familiar terms. The deeper discomfort, the real discomfort is not magnetism. It's the realization that the universe is not built the way we expect it to be built. We want gears. We get geometry. We want pushes. We get transformations. Why motion is not just a detail. Motion is not an add-on. It is fundamental. Forces are not absolute things sitting in space. They depend on how observers relate to systems. This is not negotiable. Magnetism exists because reality allows different observers to disagree and still be correct. Why this doesn't make magnetism less real. Some people think this makes magnetism an illusion. It does not. The force is real. The effects are real. The energy transfer is real. What's unreal is the idea that there must be a hidden machine underneath. What magnetism is really teaching us? Magnetism is teaching us that reality is relational. Explanations are frame-dependent. And intuition trained on everyday objects is a poor guide at fundamental scales. That's a hard lesson, but it's an honest one. Where this leaves us, at the end of part 2, magnetism should feel both clearer and more disturbing. Clearer, because you now see it cannot be separated from electricity and motion. More disturbing, because the explanation depends on how space and time themselves behave. And that raises the next question, naturally. If magnetism depends on space-time structure, why does matter respond to it the way it does? Electrons, spin, and why magnetism still refuses to feel real. By now, magnetism should feel less mysterious in one sense and more mysterious in another. We know it is tied to electricity. We know it depends on motion. We know it is built into the structure of space and time. And yet, when you hold a magnet in your hand, none of that feels satisfying. So naturally, people look for something solid, something tangible to grab onto. That's where electrons enter the story. The tempting explanation, electrons are tiny magnets. This explanation is everywhere. Electrons have something called spin. Spin creates magnetism. Therefore, magnetism comes from spinning electrons. It sounds neat. It sounds mechanical. It sounds final. And it is deeply misleading. Why spin is a dangerous word. The word spin is one of the worst names in physics. It makes you imagine a little ball rotating like a top. Electrons do not do that. If an electron were literally spinning in space, parts of it would be moving faster than the speed of light. That alone tells you the picture is wrong. Spin is not motion. It is a property. Calling it spin is historical baggage, not explanation. What spin actually is, without pretending it's intuitive. Spin is a built-in feature of particles. It is not something the particle is doing. It is something the particle is allowed to have. When we measure spin, we are not watching a rotation. We are probing how the particle responds to certain interactions. That's all. If that feels unsatisfying, Good, it means you're being honest. Why electrons behave like tiny magnets anyway? Despite all that, electrons do behave magnetically. They respond to magnetic fields. They create magnetic effects. But this does not come from a spinning object in space. It comes from how quantum particles interact with fields. Again, magnetism refuses to become mechanical. Why this makes atoms magnetic? In atoms, electrons occupy states. Some of those states have magnetic effects. Some cancel each other out. If everything cancels, the atom is not magnetic. If something remains unbalanced, the atom has a magnetic moment. That's it. No little bar magnets inside. No gears. No spinning balls. Just rules and allowed states. Why most materials are not magnetic? Most materials contain electrons whose magnetic effects cancel out. Nature seems to prefer balance. So in most materials, magnetism disappears at large scales. This makes magnets feel special, almost mysterious, because they are exceptions, not the rule. Why ferromagnetism feels miraculous? In materials like iron, something unusual happens. Electron spins align, not because they want to, but because certain interactions make that alignment energetically favorable. Once aligned, they reinforce each other. Suddenly, a macroscopic magnetic field appears. This is one of the rare cases where atomic scale effects survive averaging. That's why magnets feel magical. Why alignment is not intention. People say spins want to align. They don't. Alignment happens because other arrangements are unstable. There is no preference, only allowance. This distinction matters because magnetism feels purposeful when it isn't. Why quantum mechanics doesn't rescue intuition? At this point, many people hope quantum mechanics will finally explain magnetism. It doesn't, at least not in the way they want. Quantum mechanics gives us rules that work perfectly, but those rules are abstract. They do not tell stories about parts pushing parts. They replace mechanism with mathematics, and magnetism lives comfortably there. Why explanation stops feeling human? The deeper we go, the less magnetism resembles anything in everyday experience. No spinning tops, no invisible ropes, no pushing hands, just properties, constraints, and interactions. At some point, explanation stops being something you can picture and becomes something you accept because it works. Why this feels like failure but isn't? It feels like failure because we equate understanding with visualization. Physics does not. Physics equates understanding with predictive consistency. Magnetism meets that standard completely. It just refuses to meet the emotional one. Why asking what causes spin goes nowhere. People often ask, what causes electron spin? Nothing. It is not caused. It is part of the definition of the particle. Asking what causes it is like asking what causes a triangle to have three sides. That question has no deeper answer. Why this is unsatisfying and unavoidable. We want deeper causes. Nature offers deeper rules. At some point, explanation ends not because we are lazy, but because the universe is built that way. Magnetism lives at that boundary. The real lesson hidden here. The lesson is not about electrons. It's about explanation itself. There are two kinds of why. Why in terms of mechanism. Why in terms of structure. Magnetism answers only the second. Why insisting on mechanism breaks understanding. If you insist magnetism must be mechanical, you will misunderstand it forever. You will invent pictures that feel good and explain nothing. The correct explanation feels worse and explains everything. Where this leaves us, by now, magnetism should feel mathematically precise, experimentally confirmed, conceptually uncomfortable, and that is the correct state to be in, because magnetism is not weird because we don't understand it. It's weird because reality is not built the way we expect. There is one question left, and it's the hardest one. If magnetism is built into the structure of particles, fields, and space-time itself, why does the universe allow such a structure at all? Physics does not answer that, but understanding where explanation stops is part of understanding. Why magnetism may never make sense. and why that is not a failure. By now, you may feel something unusual. Not confusion, but a kind of tension. You understand magnetism better than before, and yet it feels less settled, not more. That feeling is important. It means you are finally taking the subject seriously, because magnetism does not reward comfort. It rewards honesty, the expectation that causes all the trouble. There is a hidden expectation behind almost every question about magnetism. It is the expectation that everything must be explainable in terms of familiar causes, pushes, pulls, collisions, motions we can picture. This expectation is never stated, but it controls how people judge explanations, and magnetism refuses to obey it. The mistake of demanding one more layer. People often think that if we just dig deeper, we will eventually find the real mechanism. They imagine that behind fields there must be something moving. Behind spin there must be something rotating. Behind interaction there must be something pushing. But this idea that there is always another layer is not a law of nature. It is a habit of thought where explanation actually ends in physics. Physics does not explain things by uncovering hidden machinery forever. It explains things by discovering rules that cannot be reduced further. At some point the answer to why becomes, because that is how the universe behaves. This is not laziness. It prevents nonsense. Why magnetism hits that boundary so clearly? Magnetism reaches the boundary of explanation faster than most phenomena because it involves fields that are not substances, properties that are not motions, forces that depend on frames of reference. It strips away the last remnants of mechanical intuition. What remains is structure. Why structure feels unsatisfying to the human mind? The human mind evolved to survive. It did not evolve to accept abstract rules without pictures. So when physics replaces mechanisms with structure, it feels like something has been lost. But nothing has been lost, only illusion. Why it doesn't make sense is often the wrong complaint. When people say magnetism doesn't make sense, they usually mean, I can't imagine it doing something. But imagination is not the standard of truth. Consistency with experiment is. Magnetism passes that test perfectly. Why understanding is not the same as familiarity. There is a dangerous idea that if something feels familiar, it is understood. That idea is false. Familiarity often hides misunderstanding. Magnetism refuses familiarity, and that is a virtue. Why asking what causes the field goes nowhere. At some point, you must stop asking for causes and accept descriptions. A magnetic field is not caused by something else in the way smoke is caused by fire. It is part of the description of how reality behaves under certain conditions. Asking for a cause beyond that is like asking what causes space to have 3 dimensions. It's not that the question is deep, it's that it is misplaced. Why this is not unique to magnetism. Magnetism is not special in this respect. The same issue appears with quantum probability, the speed of light, space-time, geometry. Magnetism just happens to make the problem visible. Why physics does not promise emotional satisfaction. Physics does not exist to comfort intuition. It exists to prevent us from lying to ourselves about nature. If honesty feels uncomfortable, that is not physics' fault. The real achievement of understanding magnetism does not mean you can explain it to a child using marbles and strings. It means you know where pictures stop working, where mathematics takes over, and where explanation must honestly stop. That is real understanding. Why pretending to understand is worse than admitting mystery. Many explanations of magnetism exist only to protect confidence. They replace mystery with metaphor and call it clarity. This is not education, it is decoration. Admitting that something does not reduce to familiar ideas is not weakness, it is intellectual integrity. Why magnetism is not unexplained. Magnetism is explained as far as explanation is possible. What it does, how it behaves, how it relates to other phenomena. What it is like in human terms is irrelevant. Nature does not speak human. Why this changes how you think about knowledge. Once you accept magnetism on its own terms, something subtle happens. You stop demanding stories. You start respecting structure. This shift changes how you approach everything you don't immediately understand. Why the universe does not care about mental pictures. The universe does not reward imagination. It rewards accuracy. The fact that magnetism works without caring whether we like the explanation is one of the strongest pieces of evidence that physics is discovering something real, not inventing stories. The deepest discomfort and the deepest lesson. The deepest discomfort is realizing that reality is not obligated to make sense to us. The deepest lesson is realizing that we can still understand it anyway. But understanding now means accepting limits, respecting abstraction, and abandoning the demand for familiarity. That is maturity in science. Why not making sense is the wrong conclusion. Magnetism does not fail to make sense. It fails to make human sense. That is a very different thing. The quiet conclusion. Magnetism is not strange because it is mysterious. It is strange because it reveals something uncomfortable. The universe is not built out of mechanisms we recognize. It is built out of rules we must accept. Once you accept that, magnetism stops being frustrating. It becomes instructive. What magnetism finally teaches us? Magnetism teaches us that explanation has limits. Intuition is optional. Honesty is essential. And that sometimes the most accurate answer to why is because that is how nature works, and it works perfectly. The final thought: if magnetism still doesn't make sense to you, good. That means you are no longer confusing pictures with reality. You are seeing the universe as it actually is. Not familiar, not mechanical, but astonishingly consistent. And that is enough.